Assalamualaikum warahmatullahi wabarakatuh. Hello, my name is Rizka Shifa from 11.5. Today I want to present about the visible light. Okay, first is, do you know what is visible light? The visible light is the segment of the electromagnetic spectrum that the human eye can see. And the next question, why the visible light can see by the human eye? Human only can see the wave that has a wavelength between 780 to 380 nanometers and the frequency between 400 to 790 terahertz. And the visible light has a wavelength between 780 to 390 nanometers and the frequency between 416 to 789 terahertz. This is the spectrum of electromagnetic, and I will focus with the visible light. Visible wavelength pass largely uninterrupted through the Earth's atmosphere via the optical window region of the electromagnetic spectrum, and the wavelength of the visible light is 0.5 10 to the minus 6 meters, and the approximate scale of wavelength is like protozoans, and the frequency is 10 to the power 14 to 10 to the power 15 Hz, and the temperature of object at which this radiation is the most intense wavelength emitted at 10,000 Kelvin. And this is the spectrum of visible light. The spectrum does not contain all the colors that the human visual system can distinguish, and saturated colors such as pink or purple variation like magenta, for example, are absent because they can only be made from a mix of multiple wavelengths. Colors containing only one wavelength are also called pure colors or spectral colors. This is the color with their frequency and their wavelength. The mechanism. If white light passed through the prism, it can be separated into light of different colors. These colors are red, orange, yellow, green, blue, indigo, and violet. The different colors of light revealed when white light is passed through the prism are called the visible spectrum. And this is the visualization of the visible light. Based on this picture, we can see that narrow beam of white light passes through the prism, and it can be separated into light with the different colors. They are red, orange, yellow, green, blue, and violet. The question is, why we use a prism? Because prism can decompose light, or it's known as dispersed light. And this is the video of experiment of the visible light. For this experiment, you will need a prism, white light, and a dark room where the reflection can clearly be seen. And the procedure. Take the prism and keep it the table. Ensure that the room is considerably dark for the light to be obvious when light travels through the prism. It splits the white light into 7 colors. They are violet, indigo, blue, green, yellow, orange, and red. And that's the video of a simple experiment of the visible light. And next is the inventors. 16th century, Roger Bacon theorized that rainbows were produced by a similar process to the passage of light through the glass or crystal. In the 17th century, Isaac Newton discovers that prism could resemble white light and described the phenomenon in his book. And Newton observed that when a narrow beam of sunlight strikes the face of glass prism at an angle, some is reflected and some of the beam passes into and through the glass, emerging as the different colored bands. Newton hypothesized light to be made of particles of different colors, with the different colors of light moving at different speeds in transparent matter. Red light moving more quickly than violet in glass. The result is that the red light is refracted less sharply than violet as it passes through the prism, creating a spectrum of colors. Newton originally divided the spectrum into 6 named colors. They are red, orange, yellow, green, blue, and violet. He later added indigo as the seventh color, and it is known as dispersed light. And next is application in our daily life. Visible light is used by plants to produce their food or photosynthesis. Visible light communicating or VLC is used for laser in fiber optic, medical, and communication. And visible light is used to treat neonatal jaundice or hyperbilirubinemia. And the last is used to spectrophotometer. Spectrophotometer is a device used to measure absorbance by passing light with a certain wavelength on a glass or quartz object called curved. Some of the light will be absorbed and the rest will be missed. And this is the mechanism of spectrophotometer. Polychromatic light from deuterium lamps is passed through the lens toward a monochromator. Monochromator polychromatic will convert the light into the monochromatic light, and the light will pass on samples containing a substance in a certain concentration. And the light that is passed in the past is then received by a detector and the detector will calculate it. The principle of spectrophotometer UV-Vis. Deuterium lamp emits a radiation in the form of light. The light passes monochromata and is dispersed by monochromatic from polychromatic light into monochromatic light, which have certain wavelength based on the sample. Monochromatic light passes through the sample containing a substance with a certain some light is absorbed, and another is passed. The light is passed to the detector. It changes from light to electrical signal. Electrical signal is read as absorbed by the recorder, and that's how the spectrophotometer works. And next is conclusion. Visible light waves are the only electromagnetic wave that we can see. The visible light has wavelength between 780 to 390 nanometers and the frequency between 416 to 789 terahertz. Roger Bacon is the first person who trademarked the spectrum shown in a glass of water, and Sir Isaac Newton was the first to test the visible light from the sun that can divide it into several colors. And visible light can be used for photosynthesis, spectrophotometer, and also in the medicines. And that's all from me. Thank you for watching and Assalamualaikum warahmatullahi wabarakatuh.